Hello everyone, welcome to my channel. This video is in continuation to my previous video. In this video, we will discuss section B of my 2019 paper of Mathematics-1. So just have a look at the at section B of the question paper. Section B consists of 4 questions. You have to do at least 2 questions from section B and at least 2 questions from section C. So let's start from 11th question A part. Expand f of x is equal to sine inverse x by Maclaurin's theorem. I would suggest that if such kind of question come whose derivatives are very difficult to find out, then you should not do this kind of question because the derivative Maclaurin's theorem uses the derivatives, right? So derivative of sine inverse x is 1 upon under root 1 minus x square. Then further you have to find out the second derivative, third derivative, fourth derivative, and you should get some relation in that, which is quite difficult to find out. So I suggest that if such kind of question comes in which the derivatives are very difficult to find out, then don't do this kind of question because you have choice of doing other questions also. Okay, so but I will give you solution to this, so let's do it. So Maclaurin's theorem is given by this formula: f of 0 plus x times f dash 0 plus x square upon 2 factorial f double dash 0 plus x cube upon 3 factorial f triple dash 0 plus x to the power 4 upon 4 factorial f fourth derivative at 0, and so on like this. So we'll find out these derivatives. Function is sine inverse x. Firstly, the value of the function at 0 is sine inverse 0, which is 0. Now find the derivatives. F dash 0 is 1 upon under root 1 minus x square, which is 1 minus x square to the power minus 1 by 2. Now, what is the value of f dash at 0? It is equal to 1. You can put x equal to 0 here and you will see you will get the value of the derivative of the function at 0 to be 1. Now find the second derivative, f double dash 0. It will be minus 1 by 2, 1 minus x square to the power minus 3 by 2 into derivative of 1 minus x square. Derivative of 1 minus x square is minus 2x, right? So this 2 will get cancelled with this 2. Minus minus will become plus. So we get x into 1 minus x square to the power minus 3 by 2. Now if you put x equal to 0, we get the second derivative to be 0. Okay, so in this case the even derivatives will come out to be 0. Okay, if you will find out the even derivatives of sine inverse x will come out to be all 0. So in this expansion only odd powers of x will appear. Now find out the third derivative. So we can apply chain rule here. Not the chain rule, product rule here, u into v. So let's apply u into v formula here. So 1 minus x square to the power minus 3 by 2 as it is into derivative of x. Derivative of x is 1 plus derivative of 1 minus x square to the power minus 3 by 2, which is minus 3 by 2, 1 minus x square to the power minus 5 by 2 into derivative of 1 minus x square. Derivative of 1 minus x square is minus 2x, and 1x will be multiplied with it, so it will become minus 2x square. So this and this will give me plus, and 2 get cancelled with 2, so we get 3x square, 1 minus x square to the power minus 5 by 2. Now if you put x equal to 0 here, okay, let's see this. If you put x equal to 0 in the third derivative, we get the value of third derivative at 0 to be 1. Now let's find the fourth derivative. Fourth derivative will be equal to minus 3 by 2, 1 minus x square to the power minus 5 by 2 into derivative of 1 minus x square, which is minus 2x, plus 3x square minus 5 by 2, 1 minus x square to the power minus 7 by 2 into derivative of 1 minus x square, which is minus 2x, plus 1 minus x square to the power minus 5 by 2 into derivative of 3x square, which is 6x. Now if you cancel out this and this, and this will become plus, so it is 3x. 3x and 6x will give me 9x. So it is 9x, 1 minus x square to the power minus 5 by 2 plus 15. This will become 15. You can see 2 will get cancelled with 2. minus minus will become plus. So it will become 15x cube 1 minus x square to the power minus 7 by 2. If you put x equal to 0, here the fourth derivative will come out to be 0. Now the fifth derivative, again apply u into v formula on this and on this also. Okay, I hope you can do it yourself and you will see you will get this. Okay, you can do it yourself and you will see you will get 4 terms like this. Now if you put x equal to 0 here, this will become 0, this will become 9, this will become 0 and this will also become 0. So the fifth derivative at 0 will be 9. So we have got these values of the derivatives at point 0. You can put it in Maclaurin's series. Okay, you can put all these values here and you will get the expansion of sine inverse x. So expansion of sine inverse x is x plus x cube upon 3 factorial plus 9x cube upon 5 factorial and so on. And this completes 11th question A part. Now 11th question B part, limit extending to a x to the power a minus a to the power x to the power x minus a to the power a. You can see this is a 0 upon 0 form. When you put x equal to 0, it will be 0 upon 0 form. So we have to solve it by L'Hopital rule. We'll apply L'Hopital rule here. So just take the derivative in numerator and denominator also. This is x to the power a can be any number. So this is of the form x to the power n. So derivative of x to the power n is n x to the power n minus 1. Then derivative of a to the power x is a to the power x log a. Derivative of x to the power x is x to the power x 1 plus log a. And a is constant, so a to the power a will be constant. So the derivative of this will be 0. Okay. Now if you put the value of x equal to a here, you get a to the power a minus 1 minus a to the power a log a divided by a to the power a 1 plus log a. So you can take out a to the power a common from the numerator. It will be 1 minus log a upon a to the power a 1 plus log a. A to the power a will get cancelled with a to the power a. So we get the answer 1 minus log a upon 1 plus log a. This completes 11th B part. Then 12th A, find the integral in terms of gamma function. The function is 0 to 1, 1 upon under root 1 minus x to the power 4 dx. We know that in gamma function, the upper limit is always infinity, right? So what we will do, we will try to make the beta function from here, and then we will use the relationship between beta and gamma function to express this integral into gamma function. Okay, so here we can make this integral firstly in the form of beta function. So I'll make the substitution here, x to the power 4 to be t. So x to the power 4t, so 4x cube dx will become dt and dx will be dt upon 4x cube. Now you have to put the value of x here in terms of t. So the value of x in terms of t, you can see from here, x is t to the power 1 by 4. Right? So when you put t equal to 1 by 4 here, you get t to the power 3 by 4. So dx is dt upon 4, t upon 3 by 4, which is t to the power minus 3 by 4 dt by 4. Now just put these values in the integral. So integral becomes 0 to 1, 1 upon under root 1 minus t. Instead of dx, we have put t to the power minus 3 by 4 dt by 4. Now let's solve it further. We can take 1 by 4 outside and we will make it of the form of beta function. Minus 3 by 4 can be written as 1 by 4 minus 1 and 1 by 2 can be written as 1 by 2 minus 1. So this is of the form of beta mn. Okay, so this is beta 1 by 4, 1 by 2. And we know the relationship between beta mn. Beta mn is equal to gamma n divided by gamma m plus n. So we will use that relationship here. 1 by 4 gamma 1 by 4 gamma half upon gamma 1 by 4 plus half. So this is equal to gamma 1 by 4 gamma half 1 by 4 times gamma 1 by 4 gamma half divided by gamma 3 by 4, and hence we have expressed the given integral into the form of the gamma function. This completes 12a. And then next question, 12b. Find the maxima of f of x equal to 2 times x square minus y square minus x to the power 4 plus y to the power 4. So to do this, firstly we have to find out the partial derivatives of this function. So partial derivative of this function with respect to x, it is, if you take derivative here, it will be 4x, right? It will be 2x, 2 multiplied by 2, it will become 4x minus 4x cube. Now take the partial derivative of this function with respect to y. So it will be minus 4y plus 4y cube. We'll equate these two equations equal to 0. So solve 4x cube minus 4x minus 4x cube equal to 0. Take out 4x common. Using one equation, take out 4x common. So you get 1 minus x square. From here you get the value of x to be 0, 1 and minus 1. Similarly, we'll solve the second equation. So solve the second equation. This is second here. Solve the second equation. So minus 4y, 1 minus y square equal to 0. You get the value of y to be 0, 1 and minus 1. So we get 3 values of x, 3 values of y. So these 3 values of x and 3 values of y give us the 9 points because we'll take their combinations. So a value of x, when value of x is 0, y can be 0, y can be 1, y can be minus 1. Then if x is 1, y can be 0, y can be 1, y can be minus 1. And then when x is minus 1, y can be 0, y can be 1 and y can be minus 1. So we get 9 points. From these 9 points, we have to find the point of maxima. Okay. Now let's find out the second derivatives. A which is equal to 2 times derivative of the function with respect to x. You can see this will come out to be 4 minus 12x square. B will come out to be 0. If you take the derivative of this function with respect to y, it will come out to be 0. And 2 times derivative of the function with respect to y is minus 4 plus 12y square. Okay, so we get the value of A, B and C. Now for maxima, we have to find out maxima, right? Now to find out, now to get the maxima value, the maxima occur when AC minus B square is greater than 1 and A is greater than 1. A is less than 1, sorry. Greater than, for when A is greater than 1, then minima will occur. For maxima, AC minus B square should be greater than 0 and A should be less than 1. Okay, so A less than 1 means 4 minus 12 square should be less than 1. That means 4 should be less than 12x square, which means 1 by 3 should be less than x square. 1 by 3 should be less than x square means the value of x square should be greater than 1 by 3. Okay, and x square can be greater than 3 only when x is either 1 or x is, there are 3 values of x. We have got 3 values of x now, 0, 1 and minus 1. So only 1 and minus 1 will satisfy this condition. Okay, only 1 and minus 1 will satisfy this condition. X equal to 0 will not satisfy this condition. So we are left with only 6 points. From the 9 points, maxima can occur at only these 6 points. Okay, let's further use the second condition, which is AC minus B square greater than 0. So put the value of A, put the value of C and B. So we get this. Now you can see from these 6 points, if you check for the first point, for 1, 0, if you put x equal to 1 here, what you get? You get 4 minus 12. 4 minus 12 is minus 8. And if you put y equal to 0, you get minus 4. You get minus 4. So you get 32 and 32 is greater than 0. 32 is greater than 0. So 1, 0 is satisfying this condition. Okay, 1, 0 is satisfying this condition. Now, so 1, 0 will be the point of maxima definitely. Okay, now if you put 1, 1, now try to put 1, 1. If you put 1, 1 here, so you get 4 minus 12 minus 8 and minus 8 from here, minus 8 here and if you put x equal to 1 and y equal to 1, you get minus 8 from minus 8 here, and from here you will get not minus 8, you will get 8. If you put y equal to 0, it will be minus 4 plus 12, so it will be 8. So which is minus 64, and minus 64 is less than 0. Okay, so 1 1 is not the point of maxima. Okay, 1 1 is not the point of maxima. 1 0 was point of maxima. You have seen how. Okay, then check for 1 and minus 1. Check for 1 and minus 1. If you put x equal to 1 here, you get minus 8. If you put y equal to minus 1 here, you get 8. So again, negative will come. So 1 minus 1 is also not satisfying this, right? 1 minus 1 is not satisfying this. You can check for minus 1, 0, it will satisfy. This will not satisfy, and this will also not satisfy. You can check it yourself. Okay, so only 2 points are satisfying these condition. So these 2 points are the points of maxima. So this completes this question. Now 13 question A part, show that this determinant is equal to ABC 1 plus 1 upon A plus 1 upon B plus 1 upon C. We can do this question by using elementary transformations. So what we will do, we will take out A common from the first row, take out A common from the second row, and take out C common from the third row. Okay, so just take out these things common. Okay, so once you take out these things common, what we can do, the second thing is that we can in the first row we can add up the other two rows. So apply the transformation, r1 goes to r1 plus r2 plus r3. So it will be 1 plus 1 upon a plus 1 upon b plus 1 upon c. In the first row, all the elements will be this. Now what we can do, we can take out 1 plus 1 upon a plus 1 upon b, 1 upon b plus 1 upon c common from the first row. So we get this. Now you can apply the column transformation here. C2 goes to C2 minus C1 and C3 goes to C3 minus C1. It will make 0 here, it will make 0 here, and it will become easy for us to find out the determinant. So you can see you will get 0 here, 0 here. Here we'll get 1. Here you'll get 1 by b, 1 by minus 1 by b to be 0. Here you get 1 by c minus 1 by c to be 0. And here you get 1 upon c plus 1 minus 1 upon c, you get 1. Now the determinant of a lower triangular matrix is the product of diagonal elements. So you can use that property. So this determinant is 1. So we get this equal to this, which is the right hand side, and hence we have proved what is required. Now next question, 13b part, solve the equations using Cramer's rule. Very easy, Cramer's rule. So find out the determinant, write the given matrix in the form of, write the given equation in the form of matrices first. These are the matrix of the coefficient, this is the matrix of the unknowns, and this is the right hand side. Okay, then find out the determinant. You can check the determinant will come out to be minus 1. Okay, so it has unique solution. Now find out delta x. Okay, delta x, you know how to find out. Replace the first column in this determinant by the right hand side by 166. Find out this determinant. It will come out to be minus 1. So value of x is delta x upon x. So x is coming out to be 1. In the similar way, you can find out delta y. Delta y is equal to, in the determinant, replace the second column by 166, the right hand side of the equation. So evaluate this determinant, it will come out to be 5. So y is delta y upon delta. So y is coming out to be minus 5. Then delta z, replace the third column by 166 in the determinant. You can evaluate this determinant, it will come out to be minus 5. So z is equal to delta z upon delta, so which is minus 5 upon minus 1. So z is 5. So in this way, we have calculated x, y, z. Value of x is 1, value of y is minus 5, and value of z is 5. This completes this question. Now next question, 14th A. Are the vectors 2, 1, 1, 2, 0, minus 1, 2, 4, 2, 1 linearly dependent? So what we will do, we will write these vectors in a form of matrix. If the determinant of matrix is non-zero, then the vectors are linearly independent. But if the determinant comes out to be 0, then the vectors are linearly dependent. Okay, so write this in the form of a matrix and find its determinant. So determinant of this matrix, you can see it is coming out to be 2, which is non-zero. So hence these vectors are linearly independent. They are not linearly dependent. Okay, so this completes 14th A. Then 14th B question. Find rank of the matrix 5, 3, 7, 3, 26, 2, 7, 2, 10. So we can find out the rank by using the echelon form. So we'll reduce this matrix to upper triangular into an echelon form. Okay, so firstly we have to make 1 here, 1 or minus 1 here. So we'll apply the transformation. R1 goes to R1 minus 2 times R2. Okay, it will make minus 1 here. Okay, rest you can see 3 minus 2 times 26 will give me minus 49 here. 7 minus 2 times 2 will give me 3 here. Okay, now I have to make 0 here and I have to make 0 here. So I will apply the transformation. So I'll apply the transformation. R2 goes to R2 plus 3R1 and R3 goes to R3 plus 7R1. Okay, I'll apply this transformation. So it will make me 0 here. It will make me 0 here. Here you will get 26 plus 3 times minus 49. It will give me minus 121. And then 2 plus 3 times 3. 2 plus 9 is 11. Then 2 plus 7 times minus 49. You can check, it will come out to minus 341. And 10 plus 7 times 3. 10 plus 7 times 3 is 10 plus 21, which is 31. You can divide the second row by 11, divide the third row by 31. So you get minus 11, 1, minus 11, 1. And now make 0 here. Okay, make 0 here. So apply the transformation. R3 goes to R3 minus R2. So you'll get 0 in the last row. So this matrix is now in echelon form and there are only 2 non-zero rows. So rank of this matrix is 2. So this completes 14th B part, and with this we have completed section B of this question paper. I'll come up with the section C in the next video. Stay tuned to this channel. I hope you like this video. Please subscribe my channel. Thank you so much. Have a good day. Take care. Bye bye.